Hello viewers, in this video we will see the solution to week 6 assignment 6 for the course principles of communication systems 1. We will see the first question. So consider a narrow band frequency modulated signal with the modulation index beta given as input of frequency multiplier of factor n. The modulation index of the output wideband FM is so output is n times beta, n times beta. So n times beta. Option A. Second question, a frequency modulated FM signal is described. So what is the approximate bandwidth? So we have to use Carson's rule to calculate approximate bandwidth. So this is the given equation. So this is a carrier and this one is the modulating signal. This part is the modulating signal. 1 by 4 is beta. 1 by 4 is beta. This is modulation index of FM. Now Carson's rule for bandwidth estimation is BT 2 delta F plus 2 FM. Now we will first find out what is 2 delta F and what is FM and then substitute here. So beta they have given 1 by 4. So the relationship between beta and delta F. So beta equal to delta F by FM or delta F equal to beta into FM. This is equal to 1 by 4. What is FM here? So FM is 400. How it is 400? It is sine half of 800. Half of 800 is 400. Why it is half of 2 pi? Okay, 2 pi f. So therefore the frequency is 400, not 800. It is, remember, it is 400, not 800. So 1 by 4 into 400 is delta F equal to 100. So we calculate what is delta F. We also know what is FM, 400 from this, because this is the modulating signaling part. So substitute delta F and FM. So what we will get? So I have calculated here how I have shown here how to calculate delta. I have shown here how to find FM. So 2 pi FM equal to 8 pi 10 power 8. So pi cancels and then FM equal to 800 by 2. That is equal to 400. So therefore after substitution of delta F, that is equal to 100 and FM equal to 400, we are getting 1 kilohertz. Option C. 1K, option C. Third one, consider an FM signal with the instantaneous frequency. The modulation index beta of the FM signal is. So this is given FIT equal to FC plus KF AM cos 2 FMT, and this is equal to this KF AM is nothing but delta F. We call that as frequency deviation. We know it is frequency deviation. Now what we'll do, we'll use this the relationship between theta, the relation between the angle theta and the instantaneous frequency is this equation, this relation, that is 2 pi integration 0 to t then FIT dt. Okay, so what we have to do here, so we have to multiply by 2 pi on both sides. We have to multiply by 2 pi on here 2 pi, here also 2 pi, and then integrating on both sides, integrating and multiplying by 2 pi. So this becomes this, according to definition of angle theta, this the integration of FIT with 2 multiplied by 2 pi becomes theta I. This is theta I, and integration of FC becomes, it is FC becomes t FCT, but we are multiplying by 2 pi, and this becomes integration of cos theta is sin 2 pi FMT divided by 2 pi FM. So 2 pi cancels. So we'll get this delta F by FM. This is, we know that it's a beta modulation index. So where delta F is KF into AM. Here it's KF AM. Okay, now option C. It is option C. What is option C? KF AM by FM. So we know it is delta F by FM. What is delta F? KF AM by FM. KF AM by FM. That is modulation index beta. A frequency modulated FM signal is described by the equation. So find the maximum frequency deviation delta f. Again a simple problem. So fourth one. So this is the FM equation they have given. So this del 10 is the beta. We know relationship between beta and frequency deviation delta f. Beta equal to delta f by fm. Okay, let me call it this as equation 1. And this is of course AC, amplitude of the carrier. And this is nothing but frequency. This part is nothing but modulating signal. Okay, now what we'll do here is, because this is modulating signal, 2 pi fm equal to 4000 pi. So therefore fm becomes 2000, 2k. fm is 2000 or 2k. So from equation 1, this is equation 1. So from equation 1, delta f is equal to beta into fm. So beta is 10 here, beta is 10 here, fm is 2000. So multiply these two, we'll get 20,000, which is 20 kilohertz. B, option B, 20 kilohertz. Fifth one. So this is phase modulated signal. This is the phase modulated signal. Initial frequency deviation is 25. For the frequency, input frequency 150 hertz. Later, we want a multiplication factor for the frequency deviation, final frequency deviation, 25 kilohertz. But at that time, the frequency is changed from 150 to 300, increase. So what is the solution? So delta f is given 25 hertz. Required frequency deviation, new frequency deviation is 25 kilohertz. Now for phase modulation, Tm, this delta f is given by Kp m dash t by 2 pi, equation 1. So what is this m dash t? It is the derivative. Take the derivative of m of t. M of t is message signal with respect to t, and then maximize. You take the maximum of this. So we here assume that m of t is am cos 2 pi fm t. Am is equal to 1 volt. This is given here, and fm is 150 given here. So fm is 150 given, and input side of unit amplitude is given. So therefore, so what I am trying to do here is, after differentiation of this becomes 2 pi fm. Differentiation and take magnitude maximum value, will get to 2 pi fm. So and then what we'll try to do is, delta f is equal to Kp 2 pi, this relation. See, delta f equal to Kp, m dash is 2 pi fm divided by 2 pi fm. So therefore Kp 2 pi fm divided by 2 pi cancels. So Kp into fm. So what is fm now? Fm is 150 hertz. So delta f is 25 hertz. We don't know what is Kp. Kp is it is a phase constant. Kp is equal to 25 by 50. Now we'll try to find a new frequency deviation delta f dash. That is equal to this relation Kp. This the same formula, Kp 2 pi fm by 2 pi. Kp 2 pi fm dash. Instead of fm, it is fm dash divided by 2 pi. 2 pi cancels. This becomes Kp into fm dash. So Kp will not change. It is a constant. So therefore f dash. So delta f dash is equal to. So what is Kp here? So this is Kp 25 by 150. Take here. What is fm? Fm dash? Fm dash is 300. That is given. Fm dash is 300. This is given. So what you get as new delta f dash is 50 hertz. Now what is the multiplication factor n? Simply divide the this new delta f 25k divided by this delta f. You will get 500. Answer is option C, 500. Sixth one, consider an FM signal, the frequency deviation delta f and modulation index beta. The approximate bandwidth of the signal from Carson's rule is given as. So Carson's rule, just now we discussed Carson's rule. Bt is equal to 2 delta f plus 2 fm. Or you can also write this as 2 delta f 1 plus 1 by beta. So option B, you can see here, it's option B. This is option B. 2 delta f 1 plus 1 by beta, option B. Seventh one, a frequency modulated FM signal is with a carrier frequency FC is 3 into 10 power 8, and they have given the FM equation. This is FM equation. Find the maximum frequency deviation delta F. Again, this is again a simple problem. We already solved previously this kind. So this is the given equation. So this is the carrier, and this is the modulating signal, and this is beta. Beta is equal to delta F by FM, equation 1. So from equation 1, delta F equal to beta into FM, and we know beta is equal to 6. This beta is equal to 6 here. So what about FM? So 2 pi FM equal to 2000 pi. So this is 2000 pi, FM equal to 1000. Substitute 1000 here, you will get 6 kilohertz. 6 kilohertz. Option C. Eighth one. Eighth one, consider the passband signal cos 2000 pi t. The complex pre-envelope of this signal is, we'll see eighth one. So the definition for pre-envelope is G plus, this is plus t, is equal to G of t plus J G cap t. So G cap is Hilbert transform. G cap is Hilbert transform of G of t. So G of t is equal to, this is given cos 2000 pi t, this is given. Okay, now Hilbert transform of G cap t is just sin 2000 pi t. So you just substitute here, you will get cos 2000 pi t plus j sin 2000 pi t. So this is nothing but e power j 2000 pi t. We know that e power j theta equal to cos theta plus j sin theta. Option D. Ninth one, a frequency modulated FM signal is described by. So we have to calculate again bandwidth. Again a simple problem. Ninth one. So this is the given equation. So what is this one? This is nothing but beta. This is the modulating signal. So this is our carrier. So now beta equal to delta F by FM, equation 1. So delta F is equal to beta into FM. So beta is 1 by 2, 1 by 2 is taken here, and FM is equal to 1 kilohertz because this is 2 times 2k. So 2k becomes half of that is FM. So that is nothing but 500. This is nothing but 500 hertz. So next, Carson's rule, 2 delta F plus 2 FM. So delta F is equal to 500. Substitute here, and FM is 1k, which is 1000. Substitute here, you will get 1000 plus 2000 is equal to 3k. Option D. Last one, again a phase modulated signal, a similar one, 50 hertz here, initial 50 hertz. This is for 120 hertz, and 20k is the required frequency deviation, and for the frequency 240. We have solved already. Fifth one, given delta F equal to 50 hertz, and delta F new is 20 kilohertz. 20 kilohertz. 20 kilo. Okay, 20 kilohertz. Okay. So refer problem 5 solution. Delta F equal to Kp FM. So now we come here. AM is equal to 1, FM equal to 120 hertz, FM dash equal to 40 hertz. So it's there. 50, 240, 120, and unit amplitude. This is given. So therefore, first find Kp, phase constant, from this equation, delta F by FM. So delta F is equal to 50 and 120 is here. So after finding this, delta F dash equal to Kp by FM dash. So this is nothing but Kp is this value we bring here. FM dash is 240. So you will get here this as 100. So delta F dash is 100. So multiplication factor n is nothing but delta F new divided by delta F dash. This is 20k divided by 100, which is equal to 200. So 200, option B. Thank you, viewers.